All right, next stream. So this is still on traffic car, and at the moment I am trying to use the native data, or sorry, not the native data, the baked traffic data in order to get this car to drive along it. So let me see, make sure the stuff is generally working. Control Shift B, still get those codes. Where I left off with the last time is that I had to fix the baker. And so this was the baker. I believe I had it fixed. Let's open this up. We got data. It's being stored and reloaded. So this is what I was generally expecting. Whether or not that's 100% accurate, who knows? We'll find out. Okay, so next I need to create the car script, which I had started on. Where is that? Car driver, traffic car. So traffic car has the baked traffic data, and I suppose when traffic car starts, it should pick a space to go. I'm not going to worry too much about the initialization. I'll just have it pick a spot and go for it. I suppose it should pick something that is in sight. I don't necessarily need to do a check for that. I think all of the positions will generally support where it can start driving and head to them right now. I just can't have it show up on one side of a building and have to travel to the other side of the building. It's not not to get to the first point of the navigation. Because it would generally get stuck on that. Yeah, it would. All right, big traffic. So it's going to need a point to go to. So we need the point, which is going to be, what do we store this under? That's under big traffic node, which is public. Traffic car. In order to do this, we need to know the index, int, public void start. All right. So during the start, we need to grab data. We need to grab a random point. Grab a random starting point nearby. I suppose I'll just have it pick a point. No, it should be within a region. So I'm not going to have cars everywhere in the game. I'm going to have cars appear within a certain radius around the car, around where the driver is. But it should be outside of a central sphere and a little farther away, so I've got some distance on it. Okay. Nearby. Between range. Two distances. Okay, so the traffic car, there needs to be a system that actually brings these things in. I've got these mosquitoes all over the place. Okay. Makes me have to punch the monitors with paper towels. Between two distances. Now, I need a system that's going to instantiate this, so I might as well put something in place for that right now. It would need the prefab for the car. It needs the prefab for the traffic car. We'll go with that one. All right, let's leave that one as is, go back into Unity, which has to recompile. All right, so let's expand this out. And what do we have? We have traffic system, traffic car. Okay, I'm going to change the name of traffic system right now to traffic system becomes traffic designer. And that's probably going to lose its information. Oh, but the tooling should let me build it up faster. This one's been bugging me because traffic system is more likely what would be running during runtime. And the traffic designer is what I'm using to design the traffic. There we go. Traffic designer. Hey, it automatically corrected it. Nice. Does anything else use this? The traffic baker, does that? No, it just gets the information passed into it. Okay, so that seems to be everything it needs to be. In here, let's fix the scene because I expect that traffic systems is no longer going to be there. I'll put in traffic designer. So traffic, it recognized it. Do I have... No, I renamed a folder before and that lost all the stuff, all the references. I don't remember what it was. Anyway, traffic designer. So traffic designer is still here within traffic. I'm going to rename this. There. Now, the actual cube here, does that do anything? No, it doesn't. Do I even have a reason for using that? No, I don't. Delete. Nothing. Nodes. That's the data it has stored. It still has all that. Okay, now let's check to see if this stuff works. Control Shift B, V. There. Okay, generally working. Now I need a traffic system. Traffic system should be responsible for initializing. I suppose we could call it a traffic factory, but factory is pretty much what the prefab system is. All right. So in this one, what do we got? Going back. Car traffic designer. Create empty traffic. Traffic baker, traffic. We have the traffic designer. I guess editor might be a better term in this case. But that doesn't matter. Traffic. It's just traffic. This will become the traffic system. All right, so we got freight system. Freight system? What's this? Oh, that's for the freight itself. That's not for the vehicles moving the freight. All right. So traffic, now we're going to create a new components or a new system, which is going to be traffic system. All right, create script. We can come up with a different name later. All right, traffic system. Get rid of these. Public traffic. What? Why is traffic car not available? It's in devious vigilante. Namespace does not correspond to file location. Big deal. How do I turn that one off? Control D. Okay. Yeah, with this one, do not show. All right. But why does traffic car not show up in here? Prefab. Okay, so we got a... Oh! Duh, I am outside of the actual class. Much better. It understands what I'm doing now. All right, so we have the prefab car, the traffic car, and we're going to need to instantiate some of these. We need to have a certain number of them running throughout. We'll put a limiter on this. So this will basically be a pool. And I can reset the location of items within the pool. I'm not going to worry about that right now. We'll just let each one manage itself. We just need to get a car into the system. So public void start, not public. Now this also needs to know the baker, the baked traffic. So public baked traffic. All right, to begin with, we need to pick a random point inside of here. So let's say traffic dot, and this one is just nodes. We just pick a random node. N. We'll go with node. We need traffic node, Vigilante baked traffic. Yes, that one. N equals traffic dot nodes and random dot range 0 comma, and what's the other one? Traffic dot nodes dot length. Sure, whatever. Okay, so we've got a node selected. From within that node, we should also have positions and indexes. Now, I need to get those values back out of this. Let's go into that for a second, F12. All right, so I could use some functions to make this a little bit easier. Hey, I had, this is information I was using to get that out of it. So that's a position, copy. Control X, we'll remove it from there, and we're going to put it directly into the node. All right, node position. Within this one, I have to pass in the node. Okay, now there should be a function that is broken because of this. Go with, I don't need all these debug lines anymore. There we go. Node position, and this one needs to be just node dot. What are you complaining about here? Cannot access non-static method in a static method. Am I a static method? This is not a static method. Public unsafe ref. Wait, so what was the complaint? Cannot access non-static method node position in a static context. This is not static. Okay, let's see if if Unity complains about that. Oh, I'm missing a semicolon. Get rid of that. Clear non-static field. So whatever heck is going on here. Oh, There we go. Node.node position. In this case, I'm passing in the node by reference, but we are the node. So in that case, I don't think that's necessary. I also don't need the node count. F12. Oh, yes, I do need the count. Yeah. And then that other function should be fixed. Yes, it is. Good. I no longer need to store this because I was getting the data that I needed to come through. Excellent. Next, we got all the nodes. Bake traffic. Where is my traffic system? I'm going to need to get the integer, but I think I can get that one easily enough. I just need to use it in an unsafe manner. Yeah, let's just put a function in there. Freight system, baked traffic. Here we have this one. Let's put in control CVV. We're going to go with node index. So this one doesn't take the traveling integers. We can get rid of the fixed int, and in this case, what we're trying to pass back on this is indexes. Can I just get rid of this one? Oh, it's expecting an int. Now, what's the complaint here? An expression cannot be used in this context because it cannot be passed or returned by reference. Why not? What was the code where I was actually manipulating this one? All right, code node I. Indexes. I'm just setting the value and passing that back out. I suppose I could just return the value. Is that going to come? Because it's already an integer. It's not a byte array that I have to convert. Okay, I think I'm overthinking it. So in that case, it's just that. Excellent. Okay, so we have node position, node index that I can grab at any time based on its index within the node. Traffic system. Okay, so we got traffic node set length. We've got a node now. So now I need to pick a point within that node. Oh, well, actually, node dot n dot position. We're going to instantiate the prefab in that position. So prefab var traffic car equals traffic car instantiate prefab. Okay, what does car come out as? Traffic car, which is what the prefab is. Perfect. Okay, so car, now that one's been instantiated. We're going to say car. Oh, can we instantiate with the position? So do we have the I didn't put the normals inside of this, so I don't know the angle that it needs to take on. Should I store that or should I bake it? I don't know. Okay, let's just instantiate the one that's in here now. The car will correct itself unless it's completely upside down, so we'll get to that. All right, prefab. We're instantiating the prefab, and then what rotation? Why does this not show me what the rest of the options for instantiate are? There we go, comma. Okay, transform parent, don't care. I do care about position, so that one is going to be n dot position, comma, and then it wants rotation, which is going to be quaternion dot identity for now. So the car is set up, and now we're going to say car dot transform dot look at. Oh, I need a target to look at. So to pick that, I need to know how many items are in here and pick one of those items. So I don't care which one it is at this point. What is this? Target node. Var node equals. No, not node. For this one, I need the position and the index. It needs to be. Let's go with. What was this? Traffic. It was a traffic node. Int traffic node index equals random dot range comma 0 comma car dot, is this car? No, it's n dot count. All right, so now the car dot transform dot look at. This one, I'm still in the traffic system. The car dot transform dot look at. Yeah, in this one we instantiated it needs to be rotated correctly, which I'm not dealing with rotation for the surface it's on. I'm only dealing with rotation for where it should aim to begin with. Point it in the direction it's supposed to go. Transform.look at. No, I'm already doing that. So this one's going to be n dot node position, and it wants the it wants the index, which in this case is traffic node index. So we're looking at that target destination. We need to store that target destination. We need to give it a variable. So over here on car, F12. Hey, where are you? Traffic car. Public int target index. Public vector 3 target. So now we're going to say car.target equals, traffic index No, that's not correct. That one is the target is going to be the vector 3, which is going to be this same one here. Yep. Hey, sorry, I just noticed the tasks now, or the messages. Hello. I won't be able to pronounce that. I don't recognize half the characters, but it looks like Aton. I'm probably butchering the name. My apologies. Okay, I want to tell you that you're a great professional, and it's always so interesting listening to you. Wish more DoD learning material from you. Okay, that would be yeah. I'm kind of doing a lot of the DoD stuff inside of here, bit by bit, as I'm traveling through. Um, so earlier today or the day before, I did some DoD systems, and I'll let me go back to that one for just a second. If we go over to baked traffic, this system right here, I'm using DoD, a lot of DoD in the design for the baked traffic. Basically, I might have thousands of nodes that'll be showing up, and I need to be able to access them very quickly. And I don't want to be sorting through a huge list of all the items to figure out where stuff is. So I needed to create a way to look that up and get to it quickly. Anyway, so I've got Node in here, and Node is unsafe. I'm making it serializable, and I ran into some issues where I thought that Unity wasn't supporting fixed, but it does when it serializes. So I'm definitely happy about that. I suppose it makes sense too, for it to support ECS, that they would have made sure it supported fixed. So I wonder if that was added for ECS or not, or if it's been there as part of their serialization forever. Anyway, so in this one, I've got these functions that are taking from this byte array and converting it over to an array of vector threes to grab that. But when you call the function, you give it the index of where it's supposed to show up in it, and it returns a reference to a vector three that points to the exact bytes in the memory. So when you write to it, it makes changes to it. This is largely a copy of what's being done inside of uh, the previous physics system, the one that was shown at Unite. All right. However, now I'm just using this data. So let's go back, not traffic system, that was traffic designer, baked traffic system. There we go. Okay, I don't think I do anything with end position. All right, so the target I need to have here, I also need the target index. So let's go car.target index is going to be n.node index, and that one is traffic node index. All right, so we set the values for target and target index. This is basically where the car is supposed to be headed. It's supposed to know this information. Then once it gets within range, how is it supposed to know the range? I had that in the traffic designer. It doesn't mean that information is getting carried over. So for now, I will set another one inside of here because we could tune this data to make it to fix it at this line. Traffic data multiplier. Where'd you go? Traffic system. I got a lot of code open that I don't need to have open anymore. There. Okay, that's the traffic system. We're setting that. At this point, I think that's effective enough. We're setting its target, the target index, the distance. Oh, yeah, that's right. This needs to capture the distance. So public float radius equals, and let's give the radius on this one a setting like 4 for now. It's a little bit, I think we had a radius of 3 before, so this will give it more space. All right, we create that. That should be good to go. We set the data, so effectively we instantiated the object, which is here. Now, before we start interacting with it, awake got executed. And now before we set these values in it, and then start's going to have a chance to run. So void start, grab a random position, that's already been done. This does need to have access to bake traffic. It does need to have access to the car. It is going to need a, what is this position? We need an offset, a transform. Transform dot public transform front point. What is this one? Traffic node front collider front point. The naming on this one isn't that great, so I can't come up with a good one, so I'm not going to bother with it anymore, except put in a summary that explains what its purpose is. All right, this is the... Actually, in this case, I'm not going to use this one. I'm going to use tooltip. Okay, that is not what I meant. All right, traffic. This should be a transform at the front of the car used to determine how close it is to the destination, to the next traffic node. All right, might come up with a better name later. That's fine. That's pretty long. All right, cool. Now we got that point inside of here. So traffic node point in front. We no longer need start to happen here. We're just going to start heading towards the direction that we need. Public void update. Float distance equals, I need the radius. The radius is going to be set and passed into this. So we'll go to this one, public float radius. All right, now over here we're going to say car.radius equals radius. Float.distance equals vector3.distance, and that one is the distance between 2 points. Good. So we're going to say traffic node front point comma position, and the secondary position is going to be the node. We should be storing the target, vector3 target. This dot target if distance is less than radius, pick next target. All right, let's create this, not that. Okay, so yes, void is what I want, and in this one, we need to get a new point for that's going to come from bake traffic. So we're going to say traffic dot nodes, and in that case, I need, what am I getting? Uh, oh, I need the new node. That one was taken from target index. All right, home, and we're say var n equals. So we've got a node n, and now that is the new traffic point that we have just reached. We're going to have to pick a point on that one. Now, we also need to know what the previous index was to make sure that we aren't heading back towards it. So let's also set that inside of here. Public int previous index. All right, public int previous index. Now, when I'm setting this information, I need to set the previous index, which is going to be the index of the element that I picked, traffic node index. Exactly. Okay. So car dot previous index equals traffic node index. That is the point that we started from, and then we picked an item inside of it to set the new target. So we started from that one at that point, and we're heading towards the target. Now, once we get to there, we want to make sure that we don't just turn the car around and head back. While some cars may very well do that, it wouldn't make as much sense to see a lot of cars have a reasonably high chance, like a 1/3 chance of doing that at all intersections. All right, so inside of this one, we've got a traffic. Now we need to pick a new node. So let's say public view. No, I'll pick a random one. So I picked a random position earlier using this one, so let's do the same thing. Traffic node index, n.count. So we're grabbing the positions from there. Now, if traffic node index equals, and what was the new one that we were putting in there? Previous index. Then we can't use that one. We're going to say traffic node index plus plus, and if traffic node index is greater than plus 1 is greater than n.count. So we're trying to pick one of the targets within the node, and the node has a count of them, a length of them, or a limited number. So if we exceed that, then that means we can't use this position. We're going to say traffic node index equals 0. All right. So this automatically guarantees that if we pick one at random, and if it happened to have been the previous index, we're going to move one more ahead and flip around to the beginning if we need to. Now, also in the design, I made sure that there's supposed to be a design rule in here that at any one of these points, any one of the nodes, there should be at least 3 connections leading off of it. 2 connections. There should be at least 2 connections. That way, no matter what, a car traveling through will always have a direction to go without having to backtrack. All right, so now we have traffic node index. Anything else? No. Okay, so we've selected our new target. So now we're going to set our new target. What was this one? It basically is these things. Right there. I don't need look at. That one goes away. We will be steering towards it. I don't need to reset that. Okay, so we set our new target, our target index, and we made sure to put the previous index back in place. So previous index, I do a check for it, and that was it. And here I'm making sure to set it to what our new one is. That way we go right back to where we were. Oh, wait. Previous index would equal, oh, and I reset all this stuff. So yeah, that's correct. Previous index equals traffic node index. That sets the offset. That is incorrect. That is not the traffic node index. The target is what it is for the traffic node index. Okay, I did this one wrong. Oh, I'm just selecting a random point inside of here. I don't know what index to actually use. So we're going to go to this, Control X, save that. And we're going to set int RND index equals, and we'll set it to that. And now this is going to use RND index. Thank you. And this will use RND index. That was going to be a bug. All right, previous. Mosquitoes hunting me. Well, they more tend to hunt my monitors, which I'm definitely pleased about that. Cool. All right, so let's go into here. Back up. Node. We got the traffic node. We're picking a random index within it. We've got a random index. Next, we have our target. We're setting our target from the new target index, the position, and we're setting the index for it so we can look it up later once we reach it. And then we got the previous index being set to where we are now. Now this is not correct. I need previous index to get reset. That should be target index. I should be setting that beforehand. So Control X. Oh, stop. There. Previous index is going to equal the target index. Good. So we were heading towards target index, and now we've changed that to previous index. We've set previous index to equal what we were heading towards, but we just got to there. So now it's our previous one, and our new one, target index, is one of the child elements that is not the one we were already looking at. All right, perfect, I think. That picks its next target. Okay, so the target is set. That's on the update. Now I need to get it to move. So I have a couple checks I need to do. I need to find out if the target is in front, then move forward. If the target is behind, if the target is in front, then move forward. If the target is behind, then move back. No, not move back. Then turn to face. Now I don't want it to just stop all the time, so it's going to have different angles of where it decides to turn. If the target is greater than 90 degrees from forward, push car turn towards the target if the target is less than 10 degrees from forward, stop turning. Okay. What else we got? Leave that. Okay, so target. How do we determine the target? The target is the vector 3 that we're heading towards. So we need the normal for heading towards that, which is basically our forward normal. And that one's going to be vector 3. What is that one? Target point. Target. Var forward. Let's just grab the variables. Equals transform dot forward. Okay, so the car is pointed in this direction. Next, if oh, what else do we need? We need to know the direction towards the actual object, so towards target. That would be var destination equals transform dot not transform dot forward. Let's close this in and we're going to say, what do we need? We need the target minus transform dot position. All right. So where the target is, we take away our position from it, and that gives us our direction, the difference that we need to head, and in the direction that we need to head. So now we need to normalize this. Okay. So that's our destination. Now we need to get the angle between, and we're going to say var angle equals, and that one is in vector 3 dot angle. Okay, what does it need to know? From to, calculates it to, and how is it measured? The angular difference between. Angular, so I assume they mean degrees, not radians, not not theta, or whatever it would be from passing into a cosine, the decimal. All right, so in this case, we're going to say from and to, so that is forward, comma, destination. All right, so we've got our angle. Let's just start to use this. If angle is less than 41. No, if angle is greater than 90, oh yeah, I'm still determining this one. So if angle is less than 90, that's up here still. I had to get the information first. So if angle is less than 90, we are generally facing it, then we're going to move forward. All right. Let's change that. That should be something like maybe 80, 70. Let's go with 75, not 750. If the angle difference is less than 75, let's double check that. Is this handing back degrees? F12. The angle in degrees. Okay, thank you. So we got the angle in degrees, 75. Now we have to turn toward. We're going to still move to the object. Doing it bad. Okay, so in this case, then we need to move forward, which should be this dot car dot. What commands did the car driver use? Where is that? Car driver, car driver, car driver. So in car driver, we have steering. We are enabling these. And so on this stuff, we are pressure drive. Okay, we're setting an amount of pressure to drive, to turn, to strafe. But I never... Do I have a strafe object? I guess I must, but did I ever set that up? Okay, strafe hasn't been working, but I guess I have a key set up for it that I don't remember. All right, so we got strafe. Car driver is just passing down these values. So let's go to this. Car reference. Now, car reference is the actual car. Yeah. Pressure. Okay. Pressure drive. And that pressure should be a value between 0 and 1 equals 1. Okay, that tells us to drive. Else we don't. Don't drive forward. Okay. Now, the other item that we needed to check, that effectively is this one. We need to turn towards the target. So if the angle is greater than 90 degrees from forward, turn towards the target. Well, we still need to be turning towards it as long as it is this one. So that one, this line is redundant and competes with this line of logic. So inside of this one, we need to determine if we need to turn so we are starting to face towards that target. I can reorient the second transform. I've got the, what was this one? The traffic node front point. I can alter the way that I'm only using it to determine a distance in order to get to that particular spot, to the traffic node. But I can reorient it to look at. Okay, let's do that. If angle is greater than 10, now in this one, I'm going to say, what was that? Traffic node from point. So that's TNFP dot look at, and it needs to look at the target. Okay, so this one automatically looks at the target. Now we need to start steering towards it. So we've got two sets of rotations to be able to try to determine this. Be the easiest one. In this one, I can only turn left and right. So there's a chance the car's heading this way and the next node could be that way. So it has to turn heading that way. Or it could be down on a wall here or up on a wall going up that way. And then it has to turn. So it's technically not forward, but the angle is still going to be way out there, like at 90 degrees. Actually, at that point where it transitions from wall to wall, I'm putting that as a designer rule that we make the transition from wall to wall short. All right. So if the angle is greater than 10, then we need to start heading towards it. And I can cheat on this one. I am going to say rotation.lerp transform dot rotation equals quaternion dot lerp, and we are going to lerp from our rotation transform dot rotation to now this is just to manage how the cars work. This does mean that when they first start to turn, their turning is going to be faster because it has a bigger intensity to cover up. So if I'm doing 10% change, that change is going to be biggest at the beginning and then settle down. So depending on what it's doing, there may be a kind of a jerk where it starts to move up quickly and then smoothly goes and slows down into the angle it needs to be at. And since the transitions are going to be close on the walls, this should allow it to rotate to the angle it needs. This one needs an up. Which is another point why the traffic nodes need to actually store their normals. If that took its normal, then the transition could include the up from the direction it's supposed to go. Okay, what was the size of the node data that I was storing? This is going to be another item back over towards DOD. So let's go back into this. I suppose this would also make a good point to create a separate highlight video that showcases this. But we need the node. So the node, we are holding on to 48 bytes while we have the indexes. That leaves another 16 bytes before we reach the end of this, or before we reach the end of the first cache line. So we are doing pretty well. That means I could stuff 16 more bytes in place. Now, a normal is only going to take 12 bytes. So I'm going to put a normal in here. We'll do it before the count. Public vector3 normal. All right, so this is going to be 24B. And now a count is 16, so that's going to be 28. This one is then, oh, what is this? This is 8. 8 times 4. 8 times 4 would be 32, so that should be bringing me up to 60 bytes. And then finally, We got this one, which is 8 times 12. 8 times 12, that was 96. So that's 96 plus 60. That one is 40 off of it, so 156. I suppose I should have gone through and added 12 to each one of these. That would have probably been easier on the math. And I might have gotten something wrong along the way anyway. So 156 bytes. We are now in cache line 3. Well, 144 was in cache line 3 because at 128 bytes, we've reached 2 cache lines. So we're still within our third cache line that's being read. And the third cache line is where we are giving it the mistake to start reading ahead. And no matter what, any position that we get is still going to be pushing that third cache line. I almost feel like turning this one into an object would actually make it a little bit faster because of the fact that I'm jumping to this node to begin with. So I've got the node, I'm able to go to the address directly. Now, having the direct address, you still have all that read time because it's unable to read that ahead. I really, really wish that coding would have instructions that it could pass off to the compiler, that the CPUs had instructions to say, prefetch this address, that you're suggesting pieces of information for the CPU to go do. Just tell the prefetcher to go do it because we know we're about to start working with it. It's not that all CPUs would be able to handle it. It's not that we could still make mistakes out of using it, but come on, the CPU system. Okay, so to Intel, to AMD, to whoever is producing these, or quite frankly, anyone listening who happens to be on here, if you have any idea why the CPU manufacturers, why the motherboard systems, whoever's handling this cache system, why on earth they don't give us any amount of control over prefetching? If we had an instruction to pass off, we could pass it off before we're calling on this, saying we're about to be using memory from this location and this location. So we call the variables and we say it's prefetch. That would largely even not fall onto us as the C# developers. That would be the compiler, the compiling, the MSIL code that would be sending out little prefetch notices. But it should also be something we can call. Then we get prefetching before we even need it. All right, let's go back onto this. Count indexes, positions. We got all the data in there, so that won't necessarily. That's about the worst possible case we could get for performance from trying to sequence this data. But whatever. Yeah, we're going to produce a cache. No matter what with this one, we are producing cache misses because by the time we're doing this, we read into the third one. And once we read into the third one, we have jumped 64 bytes twice in a row. So we've gotten that cache RAM, or we've gotten that cache line. And now we've gotten the third one. And when we request the third one, the prefetcher is going to kick in and say, oh, well, I'm going to go request the next one too, which means we're pulling in more memory and we don't need it. We're not going to be using it. Oh, wait a minute. 156 bytes is actually the cap. So we're only going to hit that third one if we make it to 128 bytes. And so the first one from 60 bytes out to 128 bytes, that is 68 bytes. That's an entire another cache line. That is eight, potentially not 8 positions. No, it's 12 bytes. So that's like 3 or 4. And if I'm using 3 positions that are going to be stored in this for most of these things, then it doesn't matter. It's we're going to get to this and we'll still be under that second threshold. So, okay, we're doing well here. We will likely not trigger that third one very often. Okay, cool. Okay, now, is there anything else I need to do on that one? We've got the traffic car that's supposed to be sending us. Oh, yeah, we need to rotate. So, where are we? Traffic node looks at the target. That's all that I needed there. Now, we are trying to lerp from the transform rotation, which is our car's current rotation. Oh, that's right. I changed this to start storing normals in this. Okay, so when I'm storing the normals, that's just a normal vector 3. That's got to be inside a traffic system. I'm going to have to rebake the data. Traffic system. Oh, not traffic system. I changed this to designer. All right. So in traffic designer, we can actually store this information. So let's go find this. Here's the baking, and we're passing the information in. Now this is passing in positions. It's also, am I missing something here? No. Oh, I have been getting a really weird thing. I have a GUI layout button that keeps returning true all the time. Anytime that I come back into Unity, uh, it automatically triggers the button returning a true for the first time it gets displayed. So if it returns true, then it triggers this code so it does a bake every single time I come back in. So far that's light, but as time goes on and we end up with a couple thousand nodes in here, that could get more expensive. All right. But anyway, so we've got bake. Let's go to this F12. In the bake process, we got positions because we need to know that information. However, when we're creating a node, we're going to say node dot normal equals, and we want the normal, but we aren't passing in the normals. So I'm going to have to do that. I'm going to have to produce a vector 3 of normals. Okay, let's just do that. Vector 3 normals. And that one is going to be normals I. Okay, so the baker is now collecting this information. And where do we use this one? One usage, go back. Here, and it's expecting normals now. Okay, so our normals, let's do this. Vector 3 normals equals new designer dot node dot count. Okay, so we got those, and now for the nodes, oh, every single one of these, we're going into them. Now we're also going to say normals I equals designer dot nodes I dot normal. Okay, so we got the normals, and now for this one, we are going to pass this one in. So this is normals. Done. Let's split these out because the line is getting particularly long there. Positions make sense, normals make sense, the rest of the names map out. Wait, that's radius. Okay, yeah. Distance from surface mirrors radius. Okay, where did I leave off with that? We go to positions, we got the normals being passed in. Okay, so we are now, the baking process should now include normals. So in this case, we've got the rotation, we want the up. That's right, I was fixing this so that we would be able to find the up position. In that case, the angle, we need to know what that is, so we're going to have to store it, which means our traffic car has to know where'd this go? Public vector 3 target normal. All right, target normal. So that starts to rearrange the vehicle into the angle that it needs to go in. I suppose I'll just have it drive forward all the time. And maybe it'll just be with less pressure. So equals 0.25 F. So it slows down. And that'll means it'll slow down on corners, but it should be okay. All right, so if angle is greater than 10, then we need to do a rotation with this. And we're going to cheat the system and skip forces for the traffic cars. It's still going to have the skateboards on it. And that should allow the cars to actually negotiate away from each other. Okay, traffic node, front point, look at, and it's going to look at the target. Oh yeah, we're already setting that up, but we need the new angle, which is going to be the target up. So that is target normal, target up normal. No, I appreciate that it wants to put those in there, but most of the time that I rename a variable, it's because I have just named the variable and decided to rename it before it even got used. All right, so transform rotation. Yeah, okay. And the new one that we want to be is traffic node front point dot rotation. So we're lerping between those two rotations, and the speed at which we lerp, let's make that one configurable. That will be public float lerp speed equals 1F. Okay. We can configure that at any point in time. 1F, that means 100%. No. That's, oh, but delta time. All right. So time dot delta time times, and that's going to be, what did I just call it? Lerp speed. Okay, theoretically, this one should create a single car. Where is this? We have traffic car. I need to make sure the traffic car is set up. It needs to have that front transform on it. And then the, what was the other one? The traffic system at the start is going to construct a brand new car and pick a random spot to put it on while it points it towards one of the other nodes that it will then start driving at until it reaches where it will turn to one of the other ones that it can go to. Okay. Now let's get this thing tested. I reset up the data structure, so that makes me wonder if it's going to remember this, if it's going to be able to serialize and deserialize. So I selected something, Control Shift B. It remembers the points, and okay, selection still works in here. Great. Now let's bake. It's not unhappy. Okay, that is a good sign. What do we have? We have 6 nodes, 9 mappings. Let's put one more in here just for the heck of it. Let's go, there, Control Shift B. There, I added one to there, and we're going to connect to here. And V, oh, well, V to that one. Okay, connect to this one, connect to that one, connect to that one. There. So I've just got some extra points in there. We got nodes. Let's bake it. This says we have 7 nodes. Bake. Now, if I go over to the data that baked traffic, how many do we have? 7 nodes. Okay, that's what we were expecting. Good. So it baked the data. Stop. Traffic needs the traffic system. Okay, I'm going to need a prefab for the traffic car. Uh-oh. What is... That's trailer car, and traffic car is different. All right, so traffic car... Wait, what? Where's traffic car in here? Traffic car. All right, so I got the data in here. What am I looking for? We got traffic car. This one now needs the traffic car script. Okay. So now we pass in the car script. We need the baked traffic. We need the front point. So in that case, I'm just going to create a little child element, create empty, and we're going to call it front traffic handler, whatever name. All right, now that position needs to move out closer to the front. Right about there. Sounds reasonable. Cool. Okay, so now that we got that one defined, we're going to pass it into this object. Now let's make sure that we override the original, apply all. Cool. So now that we got that value, we got the previous index, update radius, that's going to get set. The normals are going to get set. Lerp speed is already defaulted. Everything else should be okay here. So this is what's going to cause the car to start driving along those pathways. Now, inside of it, we're also expecting traffic is up here. So traffic needs the baked system. So where's that? Traffic baked? Yes. Okay, the prefab is the traffic car, which I should have. Traffic car right there. Radius is 4. Okay, is that going to work? Let's get rid of the traffic car we have in the scene. Delete. And play. Let's see, does this instantiate a car? Whoa, there's a car. And it turned. And it's also going pretty fast. What just happened? Where did that car go? Oh, there you are. What? Where are you? Okay, so I have a traffic car that's driving around. You know, I'm going to head over to here. I guess I'll go to scene view. Control Shift B. Oh, is it trying to get to this point and failing? What's its current target? Okay, so traffic car. And inside of here, it has a current target index of 5. Now, if I'm over at the traffic designer and I change the selected node, debug, selected node to 5, that's up to here. That's the one it's trying to get to? Okay, so the car's driving system is clearly not working quite right. What if I gave this more? Let's just put in some more cars, see what it does. All right, so freight, traffic designer. Because I don't exactly need this to be perfect, but that's still not making any sense. So I can't put any intelligent fixes or controls into this until I have it working as I expect the code to be working. But this is the first time I've been able to execute that. All right, so inside of this traffic node index. Oh. No, this is where I instantiate it. I want the traffic system. We instantiate this. So inside of here, let's put this, close this one up, and we're instead going to say void create car. And then here, we're going to pass this in and say create car. We'll create 3 cars. Let's see what they do. Heck, let's create more than that. There's going to be overlapping cars. No, I didn't mean it to play from here. Oh, okay. Okay. This is... They kind of look like fish swimming in a fishbowl. They travel out, they bump into things, they can negotiate traffic between each other. This is good. Okay, I am going to leave this one alone at this point in time. I'm going to call it done enough. It means I have something with cars that's driving that creates traffic. It's not the full traffic system, but I can come back to it and create additional tasks because so far, what am I up to on this one? We're hour and 23 minutes, so about an hour and a half, and I am an hour and 15 over already, so that's 2 hours and 45 minutes over the initial target time I had placed on this. So where is that? That's this one. I had originally placed 6 hours. Took 8 hours and 45 minutes. 8:45 to complete is only partially complete. This had more complexities. Okay, so what are the notes for how I'm going to leave this? 1, node system needs to get built up more. So the traffic nodes. Populate the map with traffic nodes. 2. Cars, traffic cars seem to drive okay, but do not seem to head to destinations. Display debug lines pointing out targets. Okay, if I have it display the lines to point out the targets it's supposed to go to, then that should work just fine. In this case, I am going to put this work. Hey, wait a second. Where is this one? Okay, yeah, this is in Vigilante. Why am I looking at this project? Expand this out. Why? It should be in just Vigilante. Comment. Vigilante. Okay, so yeah, traffic car right there. In this case, I'm going to create a new task that's on here. Oh, yeah, and this one should be moving over to... I don't like the names that are in here. Vigilante tasks. Let's put this to done. Done. Backlog ideas. I don't care. Delete section. Milestones. I'm going to rename this one to active. Doing. Freight truck. Do I care about the freight truck yet? Yes, I do. Freight truck has to get into here. Maybe I can pick something else first. So freight truck is basically daisy chained cars. Okay, so that one's marked as done. The next one that we were working on was the freight truck. So freight truck is supposed to be heading around here. That's this thing as well. So if, oh, stop the game. I should expand this out and put a couple of the corners on here for where I'm expecting this to get tested more aggressively. Okay, so we're inside of here. Now let's do Control Shift B. We're going to put a couple more lines. So let's go to V, and then X marks the spot. We're going to move it over here. V and X. Okay, V, X, V, X. All right. Now we're going to go create a new one. And I guess this one should be right on top. So let's move over to here. And now let's create a new one. Oh, V and X. We'll put you right up here. Put one there. Okay, now we're going to connect it to there, connect it to there. V connect to there. Z, E, X marks the spot over here. We'll put it on a connection point over here. All right, so now let's go to Z to create a new spot. B. All right. N, C, V, C, C. All right, let's put another one here. N. No, not N. There. Okay, so now let's start connecting these ones up. We got that stuff. Let's go to V. Let's connect that across. We're also going to put this one for V and C. All right. Now V. Sure, we'll just keep it like that because I hit the wrong button and I have not enabled an undo system yet. So now Control Shift B. There we go. Now let's go to V, select that one, and go C. C there. V, C, 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 V, C, 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 V, C, C, and V, C. Okay, that gives me plenty of points to work with on this grid. And I should be able to start comparing how the traffic runs around now. Let's fix this one. So now let's go V and X marks the spot to right around there. This is a high traffic corridor for the cars to actually get through. Now let's bake this. Baking was quick. I need to put in something that indicates that the baking is actually completed. Okay, but we've got 18 nodes and 30 mappings. So let's go back over to our actual data in the baked stuff. 18 nodes. All right, excellent. If I start expanding them, I can see, what do we have? 3. Oh, let's get rid of the extensions. Element 2, 4, 6. That one has 6 items in it. That one has 5. Okay. So to a certain degree, what I'm just testing for right now is I have a locked max on mappings to be a count of 8. It can't go over that. So I wanted to see how high some of these got, and I had 6 connection points showing up from some of them. Like where? Like maybe this one? Oh, those two shouldn't connect. So let's take Control Shift B. So we're going to go to V over here, and the connects, that one should be N. There, that removes that one. And then V and N. There, remove the connection between them. Bake. If it was trying to pass from that one to that one, that could be why it was messing up so much. No, it should still fix itself. Whatever. So 5. We end up having 5 as our peak count at the moment. Clear out those, and now let's go to play. Now I'll just go right back into scene view. Okay. Some of those are flying in really wacky spaces. Oh, hey, they knocked the cube off down here. Oh, I didn't account for that. Other cars can knock off the that cube as well. And there's going to be a lot of them. Okay, well, we'll come back to that. I guess that means we'll find cubes just knocked off at random, and it's kind of a normal part of driving in this sci-fi city. Okay, now the cars are also hard to notice in here, but generally, you know what? They really do need a debug view. So let's do a gizmo. That one's going to be traffic designer. I have some stuff in here that's doing the gizmo draws. There we go. Oh, colored gizmos drawing lines. That's easy. All right, so the traffic car, I want to see what it's doing, and that is going to be, what is it, draw update? Oh, because draw update is called on this one. So sure, whatever. Now inside of this code, let's head out and go to this. Draw update, no. On this one, we are going to gizmos dot color equals color dot, what color should I pick for this one? Orchid, sure. Gizmos dot, not color, dot draw line. Let's say, what does that transform? It was, the traffic car has that extra element, the traffic node front point. See. Traffic node front point dot position, comma, and the second point is where it's drawing it to, which is going to be target. Ooh, it fixed that one. That was nice. Okay, so it's just one line, and it doesn't need to be selected to do this. Let's just have them all show that. I want to see what they're trying to drive to. Select game, and we're going to play unfocused for now. Scene, play. Okay, that one's heading over to here, passes by it. What's it doing way down there? Its turn. Its turning correction is way too slow. And do any of these change? Well, look at that. It's spinning in a circle around this spot right there. I just pointed with my finger like the camera could actually see that. Okay, one of them changed targets. It was down here and it changed targets to get to this one. Let's go over to our prefab for this. Where is it? Traffic car. And then inside of this, we've got a lerp speed of 1. I want this to be a bigger number than that. Let's go to 5. 5 times faster. Nope. Let's try it again. Also, I think this is hurting the processing speed. Um, with all these physics cars in here, I was with this mode of physics model, I was looking at maybe hey, the radius. Why don't I increase the radius too? Also, their speed is chaotic. Okay. Wait, how did it go from there, that corner, all the way down to there? I think I have some broken items happening in the baking process. Oh, and that one, it was like right on the point, but it still passed over it. Okay. So let's start dealing with a couple of the issues that are happening inside of here. Radius needs to be larger, and the rotational speed needs to be faster. So let's give them the capability to do that. Oh, and the move speed on each of the individual cars should be less. All right, so traffic inside of here, we're going to set the radius up to, say, 10. Next, 10 meters might be too far. We'll find out. On the traffic cars, which is prefab traffic car, why is rigid body not accessible? That should be referenced. Maybe it automatically set it. Okay, now on this one we have traffic car, we have lerp speed. Let's increase the lerp speed again. That should keep us pointed towards the other car really well. Play. Okay, it did change position. That one got stuck upside down, but it corrected itself. Oh, because the lerp still wants to correct it. All right. Okay, so it's not perfect. Oh, its speed is still too fast. The car is moving too fast. So let's go over to the traffic car and we're going to reduce its speed. So we have different forces in here. Y force, no. Settings, distance, axis multiplier, 0.5. Is that our force mass? Impulse forward is set to 5. We're going to put that at 2, less than half speed. Okay. And steering, it doesn't pay attention to at all. So play. Let's see how this does with half steering speed. No. Half speed for the cars. Because right now they're really chaotic. What is the physics on that car doing? As it's getting closer, the physics start to go haywire. Why? It corrects its direction really fast, but what is going on there? Okay, so obviously there is something wrong with the directional system because it should not be doing what it's doing there. Stop. We're going to go to game. We're going to play focused, and we're going to go open stats because I got to see what the performance on the hardware is, what our frame rate is going to be like. Okay, we're looking at 150 FPS. And what's it like to drive around with these cars? Oh, let's turn gizmos off. Oh, there's extra lines in there. Okay. Okay, that's not bad. Okay, traffic is, wow. Yeah. Okay, so we got a couple cars here that are broken. Let's turn gizmos back on. So we got cars that get stuck, but that's okay because we'll occasionally get distances. And what's supposed to happen is that this is going to be a pool of cars. And so as we move away from an area, those cars that are stuck will eventually get flushed out of the pool and reactivated into the region in space closer towards where the car is located now, where the player is located now. Oh, and if a car heads out of boundaries on its own, because they can just follow along, and if it heads out of boundaries on its own, it'll reappear nearby. It just can't appear in view. But this works. Wait, why is my computer acting up so much? Task Manager. I want to bring this up. So GPU 3D processing is pretty maxed out on this, and that's a 2080 at the moment. CPU is fine, memory is fine. Let's hit play and see what this does. Okay, I'm gonna bring this window down so that I can have this up over here. All right, back in the view. Okay, GPU 3D, nothing else is happening here. They're traveling upside down. Okay, yeah, there's definitely an issue with the rotation on here. Just gonna hang out on the corner for a second. Oh, I have double mapped my strafe button with my speed button. That's why my strafe is messed up. That's why I can't turn on here either. Okay, got it. You go that way. All right, cool. So processing 150 FPS plus. Frame times are doing quite well. What are we doing on draw calls? 440 draw calls for this. Okay. Now, when we look at this, we're looking at under 1 million triangles and just over 1 million vertices. That's for the entire scene, but that number's changing. That means what's rendering, right? So if I go down to here, then I have very few triangles. I need to start getting some better occlusion into the scene. The camera distance. Oh yeah. Let's test this out. So if Stop. Stats can go away. I need, yeah, I'm in the game scene. That's right. Let's go over to scene view. And I'm just going to look up from here. Let's go grab the camera, main camera, Control Shift F. So now it's just looking up. Let's go to game view. Now let's set the distance that the camera can actually look. Where is the distance? The far is set at 1,000. Let's go to 100. That's going to be too short. Yep. 2, 3, 4, 5. 500 should be good enough. All right. Field of view is currently set to 60. That's fine. All right. Save this. Now let's go run this again and see what those numbers look like. How many drawing triangles? We were looking at just under 1 million triangles and just over 1 million vertices. Okay, now we're looking at 500,000 and 700,000. Okay. That is really nice driving around with these extra cars. I like the feel of it. I just need to correct them so that they actually show up where I want them to. That one drives overhead. What is that? It lerps too far. I'm guessing the rotational lerp gets caught in the angular in the angular momentum, and then it continues to lerp too fast, too far. Okay. So if that's the system, then let's go over to freight and not freight. We need to go to the traffic car. And on the traffic car, we need to set the speed for which we are lerping. And let's go to 0.5. Let's slow it down. So 2 seconds to make a complete turn. Okay. Lerp speed seems to be good. Okay, that one still goes way past its destination. Oh, but it can correct sooner. It can reach that and move past it. It just gets slower when it's not in the correct view of it. That works. Okay. Yeah, I don't need to make this perfect. I'm pleased with that setup. All right, save it. Okay, so car traffic seems to be working much better. You know what? I should take a recording of that too. Let's take a recording of a recording while I'm recording. All right. Well, if I'm going to do that, I actually have to have the stream show up in here as well. Not what I intended. Let's go to movie. Let's get rid of that one. And hey, stop there. Thank you. We got the movie. Does not have a limit. It just target FPS. I don't want single frame. Manual. Thank you. Oh, and I need to get rid of the gizmos that are on there. So turn gizmos off. turn stats off, and let's go to, well, record. Okay. Okay, I'm trying to knock the freight off. Oh, come on, that was so close. There we go. I knocked the freight off. Let's see if this still works. Inside of the game, now I need, what is it? Enter. There. We got the freight following me. Now let's put some freight right over. Hey, stop. Get away, get away, get away, get away, get away. Ah. Let's turn around and drop it. There. Oh, wait. The car was under me. Where did the freight go? All right. Where am I going now? Ah. The gravity system is a little too sensitive for navigating these parts. They're not ready for it yet. There's the cube. Ah, get out of here. There we go. Okay, enter. Grab the cube. What are you doing? Let's go to here and enter. There. Now that dropped the cube off and it should match my gravity. And now the other cars are interacting with it. Excellent. I only have one cube to play with in the game right now, but the objective is that I knock them off of trucks and then I get upgrades onto, I use that to sell and then buy and get upgrades for the car and change how the physics moves. Now, in this version of it, I'm going to be letting the physics tuning go free to the player, that they get to decide whatever it's going to do, no matter how wild and off it might be. If they get enough credit purchases, they could be moving so fast they jump out of the boundaries of the game. Okay, I'm going to stop now. Oh, what was performance like? Okay, 57% of the GPU. However, that is Let's stop this one and close this. Now, what else is the GPU being used for? We're still sitting at 60%, 73%. What's using it? Oh. Okay, it cut out a lot of the memory that was in use for it, but it seems like its performance level has actually gone up. I think what's happening is that the streaming is using hardware rendering, or it's using the GPU hardware to do this. All right, I'm gonna call it a night for right now. That is enough stuff to be done, or enough stuff is done for today. Okay, I'll talk to you all later. And also, I should be trying to get some more DoD content in here. All right, I'll talk to you later.